Hello everyone, I'm Riku Arakawa, first year PhD student at CMU. This work is done with my colleague Hiromu Yakura from University of Tsukuba and Sosuke Kobayashi from Tohoku University. I'm very happy to introduce our work, VocabEncounter, Neural Machine Translation Powered Vocabulary Learning, by presenting computer-generated usages of foreign words into users' daily lives. Vocabulary learning is of paramount importance for foreign language acquisition. However, existing educational resources often require users to have dedicated time for studying or fail to provide context and living usages of the words they want to remember, making it difficult to acquire vocabulary efficiently. To support users with their vocabulary learning, various techniques have been investigated in the HCI literature. Previous works emphasize two key directions for supporting vocabulary learning. One is microlearning, which helps users repeatedly study the words to learn by, for example, utilizing smartphone notifications. The other one is usage-based learning, which enables users to learn with phrases containing the words instead of words only, for instance, by presenting movie or article examples. Given their effectiveness, achieving both strategies will be promising. However, how to effectively combine these directions is not trivial. For example, simply presenting the usage of the words to learn within the user's daily life would not be optimal. Hence, such approaches, although promising, have not been well investigated. We introduced VocabEncounter, a novel system that transforms our daily activities into a field of vocabulary learning. Specifically, the system encapsulates foreign words to learn into materials that they are reading in the native language. By doing so, they are exposed to natural and contextualized usages of words, and they do not need to have a dedicated time for studying. To this aim, the system conducts encapsulation by generating such usages with the power of recent NLP techniques. First, it extracts an appropriate phrase from the materials. Then, it generates a translated phrase so that it contains a specified word. Finally, it replaces the original phrase in the material with the generated phrase. As a proof of concept, we focused on the approach being used during web browsing. That is, users can encounter translated phrases that contain the word they want to remember during their web browsing.
This approach possesses several challenges. For example, the translation mechanism has the possibility of presenting unnatural or mistranslated phrases. Also, it is unsure whether our approach really helps vocabulary learning effectively. Moreover, we need to examine the usability of VocabEncounter. Given that, we first evaluated the quality of translated phrases regarding their naturalness and meaning preservation by involving 60 crowdworkers. The result supported that VocabEncounter can generate the usage of foreign words with a human comparable translation quality. In addition, we confirmed that some translated sentences, less preserving the original meaning, can be filtered using a score based on sentence bot. We then evaluated its effect on learning outcome by examining whether VocabEncounter contributes to the increase of participants' correct rate between pre- and post-vocabulary test. As a result, we confirmed that our design of allowing users to encounter the words to learn within their daily browsing helps them memorize the words. Moreover, the effectiveness of presenting the generated usage is much stronger than presenting only the words, showing a clear advantage of our approach. Furthermore, we performed a long-term explorative user study in which we provided VocabEncounter to participants for a week. We then conducted semi-structured interviews to understand the usability and subject efficacy of VocabEncounter, which highlighted the benefit of combining micro and usage-based learning. For more details, please refer to our paper. Here, we show example usage of how VocabEncounter transforms our daily lives into a field of vocabulary learning. First, our implementation of VocabEncounter as a Chrome extension allows users to utilize all their time for vocabulary learning as long as they use the browser. For instance, users can learn vocabulary while they are communicating with their colleagues on Slack. In addition, VocabEncounter can be used with smartphones by developing an app. This allows users to, for example, learn vocabulary while they're reading news articles on their smartphones to pass the time of commuting by bus. Moreover, we can exploit the time spent watching movies by using VocabEncounter. The system shows translated subtitles containing the words they want to remember only for a small portion of the movies. Furthermore, it is possible to incorporate VocabEncounter with mixed reality. In this case, using text detected from a camera with OCR, the system overlays the translated phrases in the physical world using HoloLens. This is a summary of our work. We introduced a new paradigm of vocabulary learning by leveraging machine learning-based generation techniques. We show its feasibility and effectiveness by implementing VocabEncounter, which encapsulates the words to remember into material a user is reading. Our result and demonstrations open up ways to transform our daily lives into a field of vocabulary learning. Thank you for listening.